Cette section présente la première idée fondamentale de la mécanique quantique, la fusion des ondes et des particules. La fin du 19e siècle, la physique tenait de ontologies séparées. La matière régie par Newton et le rayonnement régi par Newton. Ces chapitres. Le geste générateur est le suivant. Tout objet porté simultanément des paramètres corpusculaires énergie et l'impulsion pi et des paramètres ondulatoires, la pulsation, oméga et la rage vecteur, dont des i et le vecteur dont des k. Ces deux faces sont nouées par une unique constante. Et égalé h barré oméga et puis égal h barré sillon ou le jour, ce sont les relations de Planck. Einstein est doué à la matière par de Broglie. Ce qui est doué devient un pont d'une hache barrée. Le résidu prédictif est simple, étant donné n'importe quelle entité atteint une double face liée par h barré et une amplitude dont le modulo carré est une probabilité. La trajectoire cédée à l'onde, c'est un premier contact. Le formalisme viendra au chapitre 2. This section explains how the quantum description folds a single body into one grammar. What 19th century physics kept apart, matter under Newton and radiation under Maxwell, this chapter fuses into one grammar. A single body is neither a point nor a wave. It is a wave packet, a superposition of plane waves whose amplitude psi carries all there is to know, where the squared magnitude of psi gives a probability of presence, rather than a certainty of psi gives a probability of presence, rather than a certainty of position. The bridge is one constant, welding corpuscular quantities to undulatory ones. Energy equals h times the frequency, nu. Momentum equals h divided by the wavelength, lambda. So particle and wave become two readings of the same object. The trajectory dissolves. The price is Heisenberg's relation. The spread in position times the spread in momentum is at least of order h bar, extracted directly from the packet spread. Everything downstream is this seed made rigorous in Chapter 2. Then physical in Chapter 3. This section explains the one abstraction the rest of quantum mechanics is built on. A physical state is an abstract vector, written ket psi, living in a Hilbert space E. The wave function, psi of r, is only the expression of that state in one particular basis, the ket r representation. The state itself is the vector. The wave function is one of its shadows. The whole labor of this chapter is to install that separation, the state on one side and the coordinates you happen to read it in on the other. Once the separation is made, linear algebra carries all of the physics. Observables become Hermitian operators. Measurement outcomes become their eigenvalues. Compatible measurements become commuting sets. Composite systems become tensor products. Dirac's Bra-Ket notation is the instrument that makes this representation independence visible, so that a calculation never confuses the vector with one of its shadows. It is scaffolding, the toolbox every later chapter reaches into without rederiving. This section explains why two interacting particles are secretly two independent ones. Two interacting particles are two non-interacting ones in the right coordinates. Replace the positions x1 and x2 by the center of mass and the separation. Because the coupling depends only on the difference, the Hamiltonian splits into two independent fictitious oscillators, G and R, that never talk to each other. The decoupling is a change of basis, nothing more. It is the same move that turns coupled springs into normal modes or that diagonalizes any quadratic form. Quantum mechanically, it survives because the new operators inherit the canonical commutators, so the state space factorizes. The state space of particle 1 tensored with the state space of particle 2 equals the state space of G tensored with the state space of R. Here is the catch that reveals the structure. A normal mode is a collective coordinate, not one real particle. In either mode, both real particles move. This section explains the postulates of quantum mechanics as a single structural move. 6 rules, 1 gesture, separate what a system is from what you may ask of it. The state becomes a vector in a Hilbert space, and every measurable quantity becomes a Hermitian operator. Every physical question is then answered by that operator spectrum. Its eigenvalues are the only results a measurement can return. The squared magnitude of the overlap between an eigenstate U sub n and the state psi gives the probability of each result, and the act of measurement projects the vector onto the eigenspace it selected. Between measurements, the Schrödinger equation flows the vector forward, deterministic and reversible. The whole of the theory is thus the spectral theory of self-adjoint operators on a Hilbert space plus one non-linear intrusion. That intrusion is collapse, the single place where reversibility breaks. This section explains Cohen, Tanuji's chapter 3, where quantum theory collapses to a single dictionary. This is the moment the wave mechanical improvisations of the earlier chapters harden into 5 postulates, and the whole of the theory becomes one translation table. Each physical notion gets exactly one linear algebraic counterpart. A state corresponds to a vector in Hilbert space. A measurable quantity corresponds to a self-adjoint operator. Its allowed values correspond to that operator's spectrum. A measurement corresponds to projection onto an eigenspace, weighted by the Born rule. And time corresponds to an eigenspace, weighted by the Born rule. The generative primitive is this, and observable is what it does to states. Physics becomes spectral geometry. Hold the dictionary, and every quantum question is one move, rephrased. Decompose the state in the operator's eigenbasis, then read off the probabilities. This section explains what the two-dimensional complex space does for quantum mechanics. Dimension 2 is where the theory becomes fully visible without infinite dimensional clutter. The postulates run in miniature, exact and complete. That is the chapter's office in the book. It gives you the minimal arena, the complex space. C2, where state, observable, measurement, and evolution each show their whole shape at once. Spin 1/2 is the canonical anchor, but the ammonia molecule and every optical 2-level approximation instantiate the identical structure. What carries the physics is the space itself, and the particular object is incidental. Here is the generative pattern. Every observable here is a real combination of the identity and the 3 Pauli matrices, so every state is a point on a sphere, and every evolution a rotation. Learn C2, and you can generate each next 2-state system yourself. This part explains why the 2-dimensional state space is the natural first place to test the postulates. The postulates of Chapter 3 arrive abstract. This chapter evaluates them at the smallest non-trivial object, the 2-dimensional state space, where every observable is a 2x2 matrix and prediction becomes hand-computable. Spin 1/2 is the physical instance. Stern-Gerlach fires silver atoms through an inhomogeneous field, and the classical smear collapses to 2 spots, so SZ can only be plus or minus h bar over 2. That discreteness is the seed, and the rest of the arc, angular momentum in Chapter 9, generalizes it. Here is the move to internalize. A general theory is best grasped by restricting it to its minimal arena, where the machinery still turns but nothing is hidden, and preparation, evolution, and measurement each become one visible step. This section explains why the one-dimensional harmonic oscillator sits at the center of physics. Any smooth potential near a stable minimum is, to second order, a parabola, the first non-vanishing term of its Taylor expansion. This makes the harmonic oscillator universal. It is the generic behavior of everything sitting near equilibrium, read off at leading order. Solve it once, and you have molecular vibrations, crystal phonons, and, since each mode of the electromagnetic field obeys the same equation, the quantized field itself, all at once. The chapter's real payload is that this universal system yields entirely to algebra. Its energy ladder falls out of a single commutator. The commutator of x and p equals I times h bar with no differential equation solved. The boundary is anharmonicity. The parabola holds only while the oscillations stay small. This section explains why the harmonic oscillator earns a chapter of its own among the quantum primitives. Every stable equilibrium is a parabola at the bottom. Taylor expand any potential about its minimum, the linear term dies and the quadratic survives. So the harmonic oscillator is the universal small oscillation limit that molecular vibrations, crystal phonons, and each electromagnetic cavity mode collapse onto. That is why the chapter earns a place of its own after spin 1/2. It is the second exactly solvable system, but the first infinite-dimensional one, and it teaches the purely operatorial move. The spectrum, n times h bar omega, falls out of the commutator of x and p, which equals I times h bar, together with a positivity argument alone, never touching h bar, together with a positivity argument alone, never touching a differential equation. The surprise that does the real work is equidistance. Equal gaps let you reread n, not as a label, but as a count of identical quanta, the oscillator becoming the bridge to field quantization. This section explains what an angular momentum really is in quantum mechanics. An angular momentum is anything obeying one commutation relation. The commutator of jx and jy equals I times h bar times jz. The classical construction, r cross p, is only one instance of that. The definition lives in the bracket, not in the construction. The chapter's single move is to stop defining the object by its classical form and define it instead by its algebra, three components failing to commute in a cyclic pattern. That algebra is the whole content. Everything downstream is squeezed out of those three brackets alone. The discrete spectrum comes from them. Spin comes from them too, and spin has no classical r cross p at all. This is exactly how the oscillator's whole spectrum fell out of the single relation, the commutator of A and A, dagger equals 1. The footnote names the deeper origin. This bracket is the signature of rotations in space. J is the object that generates rotation about an axis. Defined by universal behavior, not by substance. The definition then reaches objects like spin, that the classical construction never could. This section explains why angular momentum becomes a thing you recognize rather than a thing you compute. Any triple of observables whose commutators obey a single bracket relation is an angular momentum, orbital or spin or total alike. That bracket relation reads the commutator of j sub I with j sub I with j sub j equals I times h bar times the Levi. The chapter's move is to promote that commutation relation from a consequence to a definition. An object is what its algebra does. From that one bracket alone, with no wave function touched, you extract the entire discrete spectrum, the half-integer and integer values of j, and the ladder of 2, j plus 1 values of m. Quantization falls out of the non-commutativity itself. This is why one derivation covers spin, which has no classical picture at all. The algebra never needed one.